In this episode, we move into a part of operational security that is easy to overlook when everything seems to be working normally, yet it has enormous influence over whether systems stay stable, secure, and understandable over time. Configuration and patch management processes deal with how organizations control the settings of their systems and how they keep software and devices updated when weaknesses, bugs, or improvements are identified. For a beginner, these ideas may sound like routine maintenance tasks that happen quietly in the background, but they are actually central to security, reliability, and audit readiness. A company can invest in strong tools, smart people, and careful policies, yet still create serious risk if it does not know how its systems are configured or whether those systems are missing important updates. What makes this subject especially important is that poor control in either area can lead to outages, security gaps, inconsistent behavior, and costly confusion when teams try to understand what changed and why a service is suddenly acting differently. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Configuration management begins with a simple but powerful idea. An organization should know what important technology components it has, how they are set up, and how those components relate to each other. A configuration is the collection of settings, characteristics, versions, connections, and dependencies that define how a system operates in practice. That can include operating system settings, application parameters, network rules, access permissions, hardware details, and countless other choices that affect behavior. The reason this matters is that systems do not run based on theory alone. They run according to their actual configuration at a given moment, and even small differences between two systems can produce different performance, different security exposure, or different user experiences. Configuration management is the process that helps organizations keep those differences visible, controlled, and intentional rather than accidental. Without that discipline, teams may believe they are managing one environment when in reality they are dealing with a patchwork of systems that have drifted apart over time in ways no one fully understands. A helpful way to think about configuration management is to picture a building with many doors, wiring paths, locks, and support systems hidden behind the walls. The building may look organized from the outside, but if no one knows which doors were changed, which locks were replaced, or which circuits were rewired, then safety and maintenance become much harder. Technology environments work the same way. A system may appear healthy until a failure, an audit, or a security event forces people to discover that critical settings differ from what was expected. Maybe one server has a security setting disabled, one application is running an unapproved version, or one database parameter was adjusted months ago without being recorded. These are not just technical details. They shape the behavior of the environment and determine whether support teams can respond confidently under pressure. Configuration management gives the organization a controlled memory of what it has, how it is supposed to look, and what has changed from that expected state. Patch management is closely related, but it focuses more specifically on keeping software, firmware, and sometimes hardware-related code updated when vendors or internal teams provide fixes, security improvements, performance corrections, or compatibility changes. A patch may address a software defect, close a known vulnerability, improve stability, or adjust how a product interacts with other systems. Beginners sometimes hear patching described as simply applying updates, but that description is too narrow. Good patch management is a controlled process for identifying relevant patches, evaluating their importance, deciding how urgently they should be applied, testing them appropriately, deploying them carefully, verifying success, and documenting the outcome. This topic matters because unpatched systems often remain exposed to well-known weaknesses long after fixes are available. At the same time, poorly handled patching can cause downtime or incompatibility if updates are rushed into production without enough planning. Patch management is therefore not about applying every update instantly. It is about managing updates intelligently so that security improvement does not create unnecessary operational harm. Configuration management and patch management are linked because both are about maintaining control over the real state of the environment. A patch changes the configuration of a system by altering software versions, dependencies, or behavior, even when the change is meant to be beneficial. In the same way, configuration choices affect how easy or difficult it is to patch safely. If systems are inconsistent, undocumented, or heavily customized, then applying patches becomes harder because the organization cannot easily predict how one update will behave across different environments. On the other hand, when configurations are standardized and well understood, patching becomes more reliable and less disruptive. This connection is important for auditors and learners because it shows that security does not come only from adding more controls. It also comes from reducing unnecessary variation, keeping accurate records, and making sure routine maintenance happens in an orderly way. Strong processes in these areas reduce both the chance of security exposure and the chance of self-inflicted outages caused by poor control over system changes. One of the most important foundations of configuration management is the identification of configuration items, which are the systems, devices, applications, services, or other components the organization has decided must be tracked and controlled. Not everything in a technology environment receives the same level of attention, so management must decide which items are important enough to be recorded and managed formally. Critical servers, network components, major business applications, cloud resources, identity services, and important databases are common examples because changes in these areas can affect many users and business processes. Once those items are identified, the organization can define their expected state and establish accountability for keeping records current. This matters because you cannot manage what you have not clearly recognized as something worth managing. When configuration items are poorly defined, control becomes inconsistent. Some systems receive careful attention while others quietly drift, creating blind spots that only become visible when an incident, security issue, or audit review forces the organization to look more closely. A key concept inside configuration management is the baseline, which is simply the approved reference point for how a system or service is supposed to be configured. A baseline is not a magical perfect state that never changes. It is a known and accepted version of the environment that teams can compare against when they need to detect drift, validate a build, support troubleshooting, or review whether an unauthorized change may have occurred. Baselines are especially useful because modern environments change frequently, and memory alone is not enough to preserve what the organization intended. If support staff know the approved version of an application, the expected security settings of a server, or the standard network configuration for a certain role, then unexpected differences become easier to detect and investigate. Without a baseline, every system begins to feel unique, and uniqueness usually makes support harder, security weaker, and change-related problems more common. Baselines help create consistency, and consistency is one of the strongest allies of good operational control. Another important part of the process is understanding relationships among systems rather than tracking each one in isolation. A business application may depend on a database, an identity service, network connectivity, storage, and external vendor support, all at the same time. If teams only know the pieces separately but not how they connect, then both configuration management and patch management become less effective. A change or update that seems harmless on one server may disrupt an application pathway that depends on that server in a way the team did not fully appreciate. This is why good configuration management often includes information about dependencies, ownership, locations, versions, and support responsibilities. The goal is not to build a giant record that exists only for paperwork. The goal is to create usable knowledge that helps people assess impact before changes, troubleshoot faster during incidents, and understand which components need special care because they support critical services. In practical terms, relationships often explain why a small technical change can produce a surprisingly large business effect. Patch management becomes more meaningful when viewed as a cycle rather than a one-time event. The organization must first become aware that a patch exists and determine whether it applies to systems in the environment. After that comes evaluation, where teams consider what the patch addresses, how severe the underlying issue is, whether active threats are involved, and which systems are affected. Then comes prioritization, because not every patch carries the same urgency and resources are never unlimited. Some updates correct minor issues in low-impact systems, while others address serious vulnerabilities in public-facing or business-critical services. After prioritization, teams test and deploy the patch in a controlled way, confirm that systems remain stable, and document what was done. Thinking in terms of a cycle helps beginners understand that patching is not just a technical click or a maintenance window. It is a risk-based management activity that begins with awareness and ends only after the organization knows the update was successfully applied and did not create new problems. Risk-based prioritization is one of the most practical parts of patch management because it reflects the real-world truth that organizations cannot always patch everything at the same moment. Mature teams look at several factors when deciding urgency. They consider the severity of the weakness being fixed, whether the system is exposed to outside networks, how important the service is to the business, whether there are known attacks using the weakness, whether compensating controls already reduce some risk, and how disruptive patching might be if performed immediately. This is why patch management should never be reduced to a simplistic rule that all updates are equal or that speed alone proves maturity. Fast patching is useful when the risk is high and the conditions are understood, but reckless speed can create outages that damage the business in other ways. Strong patch management balances urgency with judgment. It aims to reduce exposure quickly where needed, while still respecting the fact that updates touch live services that users and business processes rely on every day. Testing and deployment deserve careful attention because many problems arise not from the idea of patching, but from how patching is carried out. A patch may be necessary and well-intentioned, yet still create compatibility issues, performance changes, or unexpected side effects in a complex environment. This is especially true when systems have custom settings, legacy dependencies, or heavy business use that differs from the vendor's general assumptions. That is why mature organizations often validate important patches before applying them broadly, especially in sensitive or high-impact areas. They also think about deployment timing, choosing windows that reduce business disruption and ensure support staff are available if something goes wrong. Controlled rollout approaches can also help by allowing teams to observe early results before wider deployment. The main lesson for beginners is that testing is not hesitation and planning is not weakness. These are practical controls that help the organization gain the security benefit of updates without turning routine maintenance into a source of avoidable instability. Even well-run environments sometimes face patch exceptions, and this is where process maturity becomes very visible. Some systems cannot be updated immediately because the patch conflicts with a vendor requirement, depends on a future upgrade, risks interrupting a critical process, or supports a legacy application that the organization cannot yet replace. An exception should not mean silence or neglect. Instead, it should mean conscious risk acceptance supported by documentation, defined ownership, time limits where possible, and compensating controls that reduce exposure while the patch remains unapplied. Those compensating controls might involve stronger monitoring, tighter access restrictions, network segmentation, or additional review of related activity. What matters is that management understands the risk and can explain why the patch is delayed, how long the delay is expected to last, and what is being done in the meantime. Weak environments treat exceptions as informal habits. Strong environments treat them as temporary, visible decisions that are tracked carefully because unmanaged exceptions can quietly become long-term weaknesses. Verification and documentation complete the process and keep it from becoming guesswork. After a configuration change or patch deployment, teams should confirm that the expected result actually occurred and that the system remains stable, secure, and usable. It is not enough to assume success because the maintenance window ended or because no one called the help desk in the first hour. Verification might include checking versions, validating service behavior, reviewing logs, or comparing the system against the expected baseline. Documentation then records what changed, when it changed, who approved it, and what the outcome was. This record matters later during troubleshooting, audit review, incident investigation, and ongoing operational planning. When records are weak, the organization loses the ability to separate known and approved changes from suspicious or accidental ones. Good verification and documentation preserve confidence that the environment is being managed intentionally rather than left to drift after each maintenance action. From an audit point of view, Configuration and patch management processes reveal whether the organization truly understands and controls its environment. An auditor is not expected to apply patches or build system baselines personally, but should be able to evaluate whether important items are identified, whether configurations are tracked and approved, whether updates are assessed and prioritized by risk, whether exceptions are documented, and whether management can show evidence that changes were implemented in a controlled manner. Weak environments usually display familiar warning signs. Inventories are incomplete, baselines are outdated or missing, patches are delayed without explanation, and no one can clearly show which systems are exposed or who is responsible for correcting the condition. Stronger environments may still have challenges, but they can explain their decisions, demonstrate oversight, and show that control processes are active rather than assumed. For a new learner, that is the most important connection. These processes are not just operational chores. They are evidence of whether management is serious about stability, security, and accountability. Configuration and patch management processes should feel much more like core disciplines of good governance than quiet background tasks that only technicians notice. Configuration management helps organizations know what they have, how critical systems are supposed to be set up, and whether those systems remain aligned with approved expectations over time. Patch management builds on that foundation by helping the organization respond to defects and vulnerabilities in a way that is timely, risk-aware, and operationally controlled. Together, these processes reduce confusion, limit security exposure, support troubleshooting, and make change safer because the environment is more visible and consistent. For beginners, the big takeaway is simple but powerful. Systems become risky not only when attackers act, but also when organizations lose track of their own technology state. Strong management in these areas keeps the environment understandable, supportable, and more resilient when business pressure, security threats, and routine change all arrive at the same time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.